From the shores of the Indian Ocean to the flight decks of modern warplanes, one name has come to stand for speed, precision and strategic bite: BrahMos. This is the story of a system that redefined the cruise missile for a new era, a collaboration between two nations, a leap in engineering, and a tool that reshaped regional deterrence. Today we walk through how BrahMos was born, what makes it distinctive, how it is used, and what the future may hold, told plainly and clearly for anyone curious about modern defense technology. BrahMos began as a bold idea: combine proven Russian missile technology with Indian systems designed to produce a fast, accurate, and versatile cruise missile. The result was a joint venture that married Russia's experience with India's growing aerospace and electronics capability. From the outset, the goal was not to produce another slow, archetypal cruise missile, but to field a weapon that could strike quickly and accurately, survive modern defenses, and be launched from land, sea, and air platforms. What made BrahMos different from many earlier cruise missiles was its speed. Where most cruise missiles loiter at subsonic velocities to preserve range and stealth, BrahMos was built to fly at supersonic speeds, typically several times the speed of sound. That speed dramatically compresses the defender's decision time. A target that might have minutes to react to a subsonic missile now has only seconds to detect, track and intercept a supersonic threat. Speed also reduces exposure to layered air defenses. The higher kinetic energy and shorter engagement window complicate interception. Equally important to speed is guidance. BrahMos uses a combination of satellite navigation and an active seeker to reach its target with high accuracy. Throughout its flight, the missile can follow pre-programmed waypoints and, in the terminal phase, switch to a radar seeker to home in on the target. Whether that target is a ship on the horizon or a fixed point on land. The result is a weapon that is flexible. It can perform anti-ship strikes or precision land attack missions with minimal collateral effects when used according to the rules of engagement. BrahMos was developed in a modular fashion so it could be adapted to multiple platforms. The land variant rides on mobile transporter erector launchers that provide mobility and concealment. The sea variant is deployed on ships where it expands naval strike options, and an air-launched version allows aircraft to deliver the missile from standoff distances. This multi-platform approach increases operational options and complicates an adversary's defensive planning. Threats can come from road mobile launchers, warships, or fast jets. Operational employment emphasized survivability and a layered concept of deterrence. Land-based units can disperse, hide, and shoot from different locations. Shipboard launchers give navies a long-range punch. Air-launched missiles provide aircraft with the ability to strike swiftly from outside the densest defenses. The combination creates a credible deterrent that, when integrated with reliable intelligence and command and control, can shape the behavior of potential adversaries without firing a shot. BrahMos has seen steady evolution from the day its first prototypes left the test range. Engineers worked to reduce weight, adapt the missile to new launchers, improve sensors and communications, and extend operational reach. Each iteration added capability to meet new mission needs or to exploit advances in electronics and materials science. Importantly, the program also emphasized reliability and maintainability so that militaries could operate the system without excessive downtime or logistical burden. Beyond hardware, doctrine mattered. Integrating BrahMos into service required new tactics, techniques, and training. Operators practiced coordinated strikes, target designation procedures, and integration with naval and air assets. Maintenance crews learned the specifics of a supersonic cruise missile's propulsion and avionics. Commanders adapted planning to account for the missile's speed and accuracy, using it to hold critical maritime choke points and strategic land targets under credible threat. Export and international cooperation grew out of BrahMos's success. Partner nations assessing their maritime security needs saw value in a fast, precise strike weapon that could preserve stability through deterrence. Export talks emphasized responsible use, adherence to international regimes, and training support, because long-range strike systems carry geopolitical weight and come with responsibilities. The joint venture's industrial cooperation also sparked local manufacturing and skill transfer where export contracts were pursued. Naturally, any discussion of a weapons system must address concerns: proliferation, escalation, and regional stability. Cruise missiles that shorten decision cycles change the character of deterrence. They can both stabilize and destabilize depending on doctrine, transparency, and command safeguards. Responsible operators invest in secure command and control, clear rules of engagement, and diplomatic channels to reduce the risk of miscalculation. Technology is only one piece of a larger strategic puzzle. Policy, communication, and restraint complete the picture. Technically, several engineering elements underpin BrahMos's effectiveness. A robust propulsion system delivers sustained high speed. Aerodynamic design minimizes drag while maintaining control at supersonic velocities. The guidance suite blends long-range navigation with terminal sensors for pinpoint hits. Survivability is enhanced through low-altitude sea ski.